So for today, we're going to continue working on solving when we have fractions, but I'm going to show you another method to do it, and it's really just by choice how you want to solve. So you can either use this new method I taught you can use the other one I taught you the other day, where you can get all the denominators to be the same and then just cross it out. So it's just really your preference on how you want to solve these and what you guys feel or think is easier, okay? So let's start here with number 1, and what I'm going to tack onto this to make this a little more interesting and make this new from the other day is that some of these now are going to have to be factored, okay? So what you want to check before you solve, now that you have a basic idea of how to solve for fractions, is you want to check to see if the items can be factored, okay? So looking at this number 1, I'm going to solve this the old way, the way that we had done it before, a few days ago or a few lessons ago, okay? So, looking at everything, looking at, where are we here? Looking at this first numerator, the second numerator, and then the denominators on the bottom here, do you see anything that might need to get factored? This n squared minus 4 has to get factored, right? So what I can do with this is, let's just rewrite the problem here. So that it's factored. So the n plus 1 on the top stays the same. The n plus 2 below it stays the same. Okay, there's my equal sign. The 10 obviously is not going to be factored, so I'm just going to rewrite it. But this n squared minus 4 can be factored, and it's a difference of 2 squares, right? It's an n plus 2, n minus 2. So here's the thing that gets a little confusing here when we end up being able to factor and solve. When you have two things that are joined together by a plus or a minus, like see how this n and 2, they're joined together by a plus, or in this case where my cursor is right now, see how the n and 2 right here, they're joined together by a minus. They cannot be separated, so they're two, you have to consider them as a whole, as a group together. So what you want to do here is, let's do this the way we did it the other day, where we looked at our denominators and we want to get them to be exactly the same thing, okay? So here is we're going to start working on this right now. So here is what I have so far. I have two fractions that are separated by an equal sign, okay? And so if you need one of everything in the denominator, what I have right now in this first one is I have an n plus 2, so let me rewrite that. But what does this first one miss that the second denominator has? So the second denominator has an n plus 2 already, but it also has an n minus 2, so you need to share the love, and you're going to have to put that n minus 2 also here. Okay? And remember, whatever you put on the top, or whatever you do on the bottom, you're going to have to do to the top. So that n plus 1 is the n plus 1 that was there originally, but since you've added an n minus 2 to the bottom, you got to do that to the top too. Okay? In the second fraction, the n plus 2 and n minus 2, they were already there. They set the tone for what the common denominator was. So all you need to do here is just rewrite it, because nothing's going to change, okay? So the common denominator for this is n plus 2, n minus 2. Now what you can do is, we've fixed all the denominators so they're all the same, and we've adjusted the numerators too. So now what you can do is, you can cross out this bottom, so this is the old way, the way I taught you a few days ago, and just now rewrite what we have left over on the top. So my next step would look like this: n plus 1 times n minus 2 equals 10, and then you're just going to FOIL these two together, right? So you're going to go n to n to 2, 1 to n, and then 1 to 2. Okay, so if you did that, you're ending up with n squared minus 2n plus n minus 2 equals 10. Okay, combine like terms. And then what you're going to do is get ready to solve this. But remember, to be able to solve these things, we have to get 0 on one side, right? So let's move this down a little bit. So if we have to get 0 on one side, let's scoot this 10 over. So we're going to subtract 10. Oops. And what I end up having is n squared minus n, and then negative 2 minus 10 is negative 12. Okay, and it looks like that. Now we can factor. We can get ready to factor now because we have 0 on one side. So this is 1 and 1. We're subtracting, remember, to get the middle number because this is a minus sign. So middle number is 1. So factors of 12, that will subtract to get to 1. How about 4 and 3? Okay. If you want to double check, here you go. 1 times 3 is 3. 1 times 4 is 4. If you subtract those guys, you're going to get the middle number, which is 1. Okay. Now who gets the prize? The 4 gets the prize. So there's minus, there's plus. Remember, when you group them going across like this. Okay. So factors for this, parentheses for this, is x minus 4, x plus 3 equals 0 because there was nothing on the other side there. So if you solve this out, remember, x minus 4 equals 0, x plus 3 equals 0. If you solve this out, this left side, you add 4. So x equals 4 there. And then for this one, subtract 3. X equals negative 3. Okay, so answers for this, x equals negative 3, and then x equals 4. So they're getting a little longer now, right, because of all these fractions and stuff. So, but all the rules still apply. And again, this was showing you how to solve using the old way. I'm gonna do example 1 and 2 solving this the old way. Then I'll do 3 and 4 showing you how to do this the new way. Okay. So here we go at number 2. First step I would do is to check and make sure if anything can be factored. Okay, so looking at all of these, actually maybe even another pre-step to do with this would be to look at this and see how this 1 doesn't have a denominator. Let's put it over 1 so that we can make it a fraction, just like what we did the other day, right? So the only thing that can be factored is this first denominator. Hopefully you can see that. And you can factor it by that crazy thing that always kills us, the GCF, okay? So on the bottom here, what's that GCF that you see? It has a GCF of b, right? So you can pull out a b from there. Okay, so that last fraction doesn't change. The second fraction doesn't change as of right now because we're just going to factor that bottom before we do any what are we missing situations here. Okay, so if we factored at the bottom, the rest of the problem still stays the same for right now because we didn't add anything new to that bottom of that first fraction. All we did was we just kind of adjusted it a little bit, simplified it. Okay, now what we do is we need to get a common denominator, so we need 1 of everything. Remember, those b minus 1s, they're glued together, so there's nothing you can do to that b minus 1, okay, because that minus is joining the b and that 1 together, so they have to, if you're going to add it somewhere, they have to go together. But I don't think we have to worry about that, I don't think, right now, right? So let's look at this first one. This first one is the one that has all of the factors already in it in the denominator. So to get I think the first one will set the tone for what all the common denominators are going to be. We want 1 of everything. It already has 1 of everything. Okay, so that stays. In the second fraction, we have a b minus 1, but what are we missing that the first fraction has on the bottom? We're missing a b, right? So it has the b minus 1. If we just put it in a parenthesis, there's the b minus 1, but it's missing that b that's in the front right there. So let's stick that right there. And if I put a b on the bottom, I'm going to also have to multiply it to the top. Okay? And then here on the last fraction, it's missing everything. So we're going to have to put a b times b minus 1 on the bottom here. We're also going to have to put a b times b minus 1 on the top, because if we did that on the bottom, we're going to have to do that on the top. Okay. Last step here is what we can do is we can cancel it out. Okay, cancel all the bottoms out because we've already gotten everything to be the same. And let's adjust now, and let's rewrite what we have in the numerator here. So we have 2 minus 2b, or 2 times b times b times b minus 1. Okay? We can simplify all of this. I'm going to draw a little squiggly here to separate the two problems. Okay? I'm going to run out of space, but here we go. We have a 2. That 2 stays. Minus 2 times b is just going to stay 2b. And then this b is going to distribute there, and it's going to distribute there. So I have b squared minus b. Okay? And so my goal right now, you guys, is I need to get 0 on one side so that I can really start to factor this and start solving. So remember, my tip for this, when we started learning how to solve by factoring, is you want to keep the squared thing, or whatever the biggest exponent is, you want to keep it positive. So right now, looking at our last line that I've written, this b squared is the highest exponent, and it already is positive. Okay, so let's not move anything on this right side. Let's move this left side, this 2, and that negative 2b. So if I do that, I'm going to be adding the 2 over to the other side, and then adding the 2b over to the other side. Okay, so when I do that, here's what I have. So if I add 2 and add 2b on that left side, everything cancels out. So all I'm left with is a 0. Okay, b squared minus b was already there. And then remember, I added that 2 from this side over, and I also added that 2b over. Now all I do is just collect like terms. Okay, and so what do I have here? Something must be wrong here. Let me check this. Oh, here we go. I'm sorry. You don't add 2b, you subtract 2b. Or I mean, you subtract 2 right here. See this step right here, you guys? You're going to end up subtracting the 2, not adding it, because it's already positive. So let me change this out here. I messed up. I apologize. Okay. So again, what I'm doing is I'm fixing this because I added this 2 over, and I should have been subtracting it because it's already positive. So to get rid of it, to cancel it out, has to be subtract. So that means that this 2 now is minus, I apologize, and this 2 is minus 2. Okay. I was looking at this and said, you can't factor this. What did I do wrong? Okay, minus and then minus. Now we can factor it, okay? So we go 1 and 1, 2 and 1. You're subtracting to get the middle number, which it's going to work out. Okay, who gets the plus, who gets the minus? 2 gets the plus, 1 gets the minus. So I end up with b plus 2, b minus 1, and now you just solve. So b plus 2 equals 0, b minus 1 equals 0, subtract 2, subtract 2, b equals negative 2. Okay. And then add 1, add 1. So b equals positive 1. And there we go. Okay, so these were the tougher ones. I actually started with the tougher ones first to show you how to factor. And so what I'm going to do on 3 and 4 is I'm going to show you another way to do this. If you don't like this canceling out the bottom thing, I'm going to show you another way to do this with some more simpler problems. But if you wanted to do it the other way, the new way I'm going to show you with these factoring problems, you can also do it too. It's just your preference. Alright, sweet people, here we go. I want to warn you about this trick, so please listen right now. If you are going to choose to solve the problems this way, you can only have one fraction on each side of the equal sign. So see here in number 3 how there's only one fraction bar here on the left side, and then on the right side there's only one fraction bar. Go back to your example 2, the original example for number 2. Just look in your notebook really quick. See how on the left side there was 2 fractions. It was like something, a fraction minus another fraction equals 1, I think it was. So the trick will not work unless you can get it to only be one fraction on each side. So once you reduce that fraction to only being 1 on each side, then you can do this trick, okay? But you can, for this to work, you can only have one fraction on each side of the equal sign. So here is how this works. It is a cross multiply, okay? So what you do is once you've gotten one fraction, I keep saying it, it's annoying, I know, but you have to know that, otherwise you're going to get the problem wrong here. So once you've gotten one fraction on each side, what you can do is cross multiply. So take the thing on the top from the first fraction and multiply the bottom thing on the second fraction to it. So what you'll have is 5 times x minus 4. So the denominator of the second fraction times the numerator of the second fraction. You're going to separate it with an equal sign and then do the same thing here. You're going to go and multiply this 4 with x minus 2. The order doesn't matter how you guys set it up. So if you put the x minus 4 first and put the 5 second, that's okay. But I think it's easier if you can put the singular number first, because it's more obvious that you have to distribute that way. If you put the 5 in the back, it's not going to be obvious. You have to distribute, okay? Same with here on the 4. If you want to put the x minus 2 in the front and put the 4 in the back, go ahead and do it, but I think it's going to be more confusing. So anyways, let's solve here. So if I distribute the 5x in, I go 5x minus 20. On the right side I have 4x minus 8, and this is just a regular chapter 1 junior high algebra problem that you could solve here, okay? So because there's no exponents on this one, you do not have to get 0 on one side. You only have to get 0 on one side when you have exponents involved, which there's none. So this is one of those problems where you get x by itself, okay, and then you want to get all the numbers on the other side. So I'm subtracting that 4x over. I get x minus 20 equals negative 8. Now add 20 to both sides. This cancels out. X equals 12, and that's it, okay? So some differences between this problem and the one that we just did is that, one, if you're going to do it using this cross-multiplying way, you can only have one fraction on each side of the equal sign. And then another rule I reminded you guys of is if you're going to solve and there's no exponents involved, you need to get all the x's on one side and all the numbers on the other, okay? Let's try number 4, and then that's it. So let's do it the cross multiply way. So I have one fraction on each side, so I know this is going to be okay. So I'm going to go 9 times 2 minus x, and then I'm going to go 4 times 3 minus x. So you take the two diagonal things there. Let's distribute these numbers in. So 9 into 2, 9 into x, 4 into 3, 4 into x, so 18 minus 9x, 12 minus x. Let's go ahead and get the x's on one side and then get the numbers on the other side. So let's change it up. Add 9x and add 9x. Okay, and then let's go ahead and subtract that 12 over. Okay, so I have, oops, where's my cursor here? 8x equals 6, divide by 8. x equals 6 over 8, and if you reduce